Hello and welcome back to Geotech Masters. In our previous videos, we learned how to describe the properties of individual particles and the overall soil mass. Today, we will focus on a very important challenge for every geotechnical professional: how to identify fine-grained soils. These are the soils where the particles are too small to see. There are three on-field tests available: dry strength, dilatancy, and toughness. These are your essential toolkit for fine-grained soils. They are described in both the ASTM D2488 and AS 1726 standards, which shows how universal they are. Mastering these skills is a critical step in your journey. Let's get our hands dirty and learn how to do it.
In this video, we will answer some very practical, hands-on questions. What are the three essential field tests that engineers use all over the world? How do we perform these simple tests using just our hands and a small sample of soil? And most importantly, how do the results of these tests help us to confidently tell the difference between silt and clay? Stay with us to find out the answers to these questions. Before we can perform any test, we must first prepare our sample correctly. We begin by selecting a representative sample of the soil we want to test. As we discussed in our Master Planning series, a good sample is one that truly represents the soil layer we are investigating. We need about a handful of material, so where do these samples come from, especially when they are deep in the ground? Often, they are recovered using a method like the Standard Penetration Test, or SPT. The SPT not only gives us a measure of the soil's strength but also provides us with this physical soil sample. If you want to master the technique of performing the SPT itself, we cover it from start to finish in our Complete Guide to the Standard Penetration Test course. Now that we have our sample, it is very important that we remove any coarse particles. These field tests are designed only for the fine-grained part of the soil. If there are particles of sand or gravel in our sample, we must remove them by hand. This is because the coarse particles will interfere with the tests and can give us the wrong result. Now that we have our clean, fine-grained soil sample with all the coarse particles removed, we need to prepare it to the right consistency for testing. This step is critical because the moisture content directly affects how the soil behaves during our field tests. We add water gradually to our fine-grained soil sample and mix it thoroughly using a spatula or our hands. The goal is to achieve a paste-like consistency, not too dry, not too wet, but just right. If the soil is too dry, it will be crumbly and won't hold together properly. This makes it impossible to perform tests like the thread rolling test or the dry strength test accurately. If the soil is too wet, it will be sticky and flow like a liquid. This also gives us incorrect results because the water is doing the work instead of the soil particles themselves. The correct consistency feels like smooth peanut butter or modeling clay. The soil should be moist enough to be molded and shaped, but firm enough to hold its form. When you roll it between your palms, it should form a cohesive ball without water seeping out, and without cracking from being too dry. This proper consistency ensures that our field identification tests will give us reliable results about the soil's plasticity and strength characteristics. Once we achieve this paste-like consistency, our sample is ready for field testing.